Hey, what up, y'all? Good morning. I called this Tailor-Made Thursday because when I was looking up the definition, it was talking about being intentionally and specifically designed for a purpose, which just kind of reminded me on the truth that we kind of grounded ourselves in the beginning of the school year, where we say, like, you have a purpose and you are not defined by a number, you are not defined by a score. And so I just want you to remember, like, in this season that you are perfect the way that you were created, and that I'm really, really proud of you guys. Also, shout out to my boy the Mouse, my brother. I know a lot of you guys understand that, Ian and Andrew especially, maybe some of my baseball boys too. Care about y'all a lot. I've put a lot of time into this lesson today. Really, really excited about it. Hope you guys enjoy it. Here we go. Alright guys, so here is our bell ringer for today. Go ahead and click pause for this video for about 5 minutes, work out the questions, and then I will be ready for you when you're ready to come back. Awesome, so go ahead and click pause in 3, 2, and 1. Alright, so this first question says a company used 1/5 box of paper each day. How many boxes will they use in 12 days? So you should know that this is going to be a multiplication question because it uses the word each. Remember, each means to multiply. So you do 1 over 5. Remember that every whole number has a 1 underneath it, so 12 over 1. And you'd get 12 over 5. Simplify that, and you get 2 2/5 boxes of paper in 12 days. So the next one says Death Valley is 595 feet below sea level. You know that below sea level means to be negative, so it is negative 595. And the absolute value is the distance away from 0. So it is a positive 595. Right here is our input-output table. And so it says identify the rule and then complete the table. So if you look at your x in order to get your y, remember it's your independent and dependent variables. So you have your y is equal to x plus 15. So 55 plus 15 is 70. 29 plus 15 is 44. 91 minus 15, 91 minus 15 is 76. 39 minus 15 is 24, and 71 minus 15 is 56. So we know that this rule is correct for our function table. Let's go ahead and zoom in right here. It says calculate the unit price. Remember, unit price means per one item or per one unit. So Amazon is selling 5 packs of cards for $27.25. Remember, we always said money goes on top when we write our ratio, and ratios can be written in fraction form. So you have $27.25 over 5 packs. Remember, we want it to be per one, so we divide both sides by 5. I'm going to use my calculator to save time for this video. And we get $5.45 per one. Now we want to compare what Walmart is selling, and they do $32.16 over 6 packs. So you do $32.16 divided by 6, and you should get $5.36 over 1 pack, because we did that by dividing by 6 on both sides. So which store has a better unit price? It is Walmart, which is true. Walmart is typically cheaper than Amazon. Amazon is just a convenience. Let's look at this Kroger question. Kroger is selling 8 bananas for $7.29. Walmart's selling 5 bananas for $4.90. It's the same process. We put the money on top. Let me get out of the highlighter. $7.28 over 8 equal to 1. So you do $7.28 divided by 8. You get 91 cents. Same thing for the next one. You get $4.90 over 5 bananas. and you get 98 cents, which shows you that Kroger has the better price for bananas. And let's look at our final question, the ratio of black moons to total. So this is a part to whole ratio. So we have 1, 2, 3, 4 black moons to 6 total moons. And we can write that as 4 to 6 or 4 to 6. Same thing as doing 2 to 3, 2 to 3, and 2 to 3. The reason why those are equivalent is because you divided both 4 and 6 by 2. Alright, so this next one. Here's some lesson statistics. Again, trying to add some memes for you, Reese. Shout out to you. And whoever else likes them. Jamie, I think you liked them. I have a surprise for you as well, buddy. So, apparently I'm going viral, which is not true when you look at my statistics, but they're going well. So 115 views on my first one on Monday, 81 on Tuesday, and then 80 yesterday. Slowly going down, but about 80 of you guys are watching, so that's pretty good. So sign up for a one-to-one conference if you guys want to still. I'm up to 41 calls. Thank you guys so much for the insights. They've been honestly really, really special to me. One, just to get to hear from you guys and see from y'all, but also to allow me to hear how can I improve as a teacher, improve like online education for you. Some of you guys, your parents reached out and said you guys are nervous or anxious to. I completely understand that if you don't want to do it, you don't have to do it at all. Had a couple students who were nervous and they ended up doing it, and I think it ended up being kind of cool for everybody. So a shout out to you, Jackson, Timon, Aya, Brody, Asher, and Lucy yesterday. Enjoyed talking to you guys, and I got about 10 more today, so looking forward to keep going. If you want to sign up, just go to the Sign Up Genius. Alright, so Tuesday, March 31st at 11 a.m., I'm going to do a Zoom meeting. So it's completely optional. It's for whoever wants to come. It doesn't matter if you're in first period, if you're in sixth period, if you're in honors or on level. It's going to be just an opportunity for us to kind of do a virtual circle, an SEL check-in, and give you guys kind of an opportunity to see one another like we would in class. And we're going to talk about certain, SEL questions and things of that nature. So I'm going to send it out on Everett. So I'm going to send text messages to everybody's parents with the meeting ID and password. So more information is to come. Be looking for a Google form, because if I only have like 3 or 4 people who are interested in this, then I probably won't do it. But my thoughts are that I'm probably going to have around 40. And then if I do, then I might make 2 different sessions. So go ahead and sign up on the Google form. That's to come later on this evening. Tomorrow, Friday, this is what I've been talking to a lot of you guys on the phone about. Really excited. We're going to take all that we've learned Monday through Thursday about geometry, and you're going to become like a little bit of an architect where you can design your own home and calculate the area. So some project ideas are going to come with that. Again, this is completely optional. It's just an experiential project-based learning for you. Should be fun. I'm going to tell you guys how you can upload it to share with other people. We're going to use a software called Padlet. And that way you guys can see other people's designs and creations too. So more information to come in that. Check your emails, and I'll also send it out in text. So today's goal, Jamie, this is for you, buddy. This is Shrek Lives On. Saw that from yesterday. That you can find the area of composite figures with some confidence. We're going to jump right in. So a composite figure is a figure made up of 2 or more two-dimensional shapes. The composite figure shows that the shown to the right is made up of 2 different rectangles. Look here, you have a rectangle here and a rectangle there. If you want to find the area with different numbers, you'd have to decompose the 2 based off of what you know. So let's go ahead and look at this shape here. If you already think you know what to do, go ahead and click pause, draw it out, and then try to figure out what is the area of this shape. If you don't, then go ahead and watch with me now. So what I see in this shape is I see a triangle, so I'm going to cut off that triangle right there. And then I also see a rectangle, which you can now tell and distinguish between the 2 shapes. So I know that the area of a triangle is base times height divided by 2. That's for a triangle. And the area for a rectangle is just base times height, or length times width. So I'm going to calculate the area of the triangle first. Now you might think right off the bat, oh, well, the height of the triangle is 10. Well, be careful because it's saying this whole line segment right here is 10 feet. So you have to look at the opposite parallel line right here to see how long is this segment. So this segment has to be 4 feet because it has to be congruent to this side. So if this is 4, the whole segment is 10, you would do 10 minus 4 in order to say, let me use a different color, that the height of the triangle is 6 and the height of the rectangle on this side is 4. Now then for the base of the triangle, we know that the whole length of the rectangle is 12. And then it also tells us that the length of this part of the rectangle is 8 feet. So if you know that this whole segment, the black plus the red, has to be 12, you can just do 12 minus 8 in order to find out what the base of the triangle is, which is 4. So then we just plug into our formulas right there. I'm going to change my color so we can see. Do 4 times 6, which is 24, divided by 2, which is equal to 12. And then we just find the area of the rectangle, which is 12 times 4, which is 48. Add them together and we get 60 feet squared. So all that that's saying is the space inside of this rectangle and the space inside of the triangle is 60 feet. We're going to try another one. This one's a little bit different. Because, you know, I'm trying to lose weight, trying to get strong. So sun's out, guns out. Got me a Ron Burgundy little meme right there. So it says Finn's Fitness has an entrance to the locker room from both the dance studio and the weight room. What is the total area of Finn's Fitness? Again, click pause, try to work this out, see if you can kind of reason through this looking at the dimensions, which means like the length and the width, to see can you find out what is the total area of this fitness area. Go ahead and click pause now, figure it out. Alright, so hopefully you saw that this is going to be a square. The weight room is a square. So if this is 28 feet, then this whole line down here has to be 28. So 28 minus 14 is 14 feet. So this little locker room segment, let me try to use it in red, is 14 feet. And if you see on this side, this whole segment has to be 30, so this whole segment has to be 30. So 30 minus 16 is 14, which also shows us that, let me try to find a color that will work. This is also a square because it is 14 by 14 feet. All right, now let's look at the dance studio. You see that this segment right here is 42 feet, which means the opposite side also has to be 42 feet. And since we know it's a square, this is 14. 42 minus 14 is 28. So this red segment is 28. This gray segment is 14. And then down here we have, let me turn this to blue. This is 33. And then this whole segment has to be 33. So we need to calculate what this red segment is as well. So if that's 33, we know that this port is 14 from before from our square. So 33 minus 14 is 19. So if we want to calculate everything, all we have to do is let's find the area of the dance studio. So area of dance is just 33 times 42. The area of locker room is a 14 by 14. And then the area of the weight room is 28 by 30. So you'd multiply all of those together. We'll multiply these, and these, and then you would add them all together. So I'm going to use my calculator. 28 times 30, which is 840. 33 times 42, which is 1,386. And then 14 times 14, which is also 14 squared, 196. Add them all together, and you get 2,422. If you're still confused, that's completely fine. What that means is the 2,422 is the space of the dance studio, plus the space of the locker room, plus the space of the weight room. So this one's a little bit easier. As you see, it's a pentagon, but every pentagon is a triangle plus a rectangle. So the only thing that's hard about this, or a little bit more challenging, is the fact that it uses some decimals. So I'm going to box out the triangle first so that we can focus on that. Now, what would be the base? There's no number here. But if you look, the base is the same length as the base of the rectangle. So we can just draw this number straight up, and we get 22.8 feet, or 22 8/10 feet. Okay, so then we have to find, it says this whole length right here is 26 5/10 feet, but the length of the rectangle is 14 5/10 feet. So we're going to subtract those two numbers, so 26 5/10 minus 14 5/10, and you get that the height of the triangle is 12. So remember, area of a triangle is base times height divided by 2. So we would do 22 times 0.8 times 12. And you get 273.6. And then we would find the area of the rectangle next. So the area of the rectangle is area is equal to length times width, or base times height. So area is equal to 14 5/10 times 22 8/10, which is 330 6/10. So what do I do now? Is that just it? Hopefully the answer is no. I got to add those two numbers together, and you get 604 20/100ths of a foot, meaning the whole space of this house is that big. So this one is also pretty easy. You see that we have a rectangle and we have a little mini triangle. So it's trying to find the dimensions of a swimming pool. Go ahead and click pause. Try to figure out what can you do, or what do you need to do in order to figure this out. Cool? Great. So if we find the area of the triangle first. Oh, that's white, so that didn't work. We know that it's going to be area is equal to base times height divided by 2. So it's going to be 6 times 5, which is 30, divided by 2. So 30 divided by 2 is 15 feet squared. 15 feet squared. And then the area of the rectangle would be 20 times 36, because area is equal to 20 length times width, which gives me, I believe, 720 off the top of my head, but 36 times 20, 720. So what do we do with these two numbers? Let's go back to the question. It says, if a cover is needed for the pool, what would be the approximate area of the cover? So we would subtract the 15 feet from this, because we don't need that to be covered, right? From the 720. So we could do 720 minus 15, which gives us 705 feet. Which doesn't really make sense to me just because of this graphic. The graphic, since this is just an indentation, you could still cover it, and so you could need 720, so I think either answer honestly would be okay. Alright, so this question's a little bit different. Let me see if I can move my pen out of the way. So we are trying to find the area of each section. So this is pretty interesting. Take a second to pause and look at each part of the rectangle, each part of the square, and see. And what I want you to figure out is how much is the length here, how much is the length here, how much is the length here, and how much is this side right there. Try to figure those out. Click pause now and let me know when you come back. Alright, so I'm going to go ahead and erase these X marks. That way we can talk about it. So if you remember anything about geometry, you should remember that opposite sides are congruent. So if this is 7 for rectangle, then this whole segment needs to be 7. So what it's telling you here, that right here this is 2, this is 2, but we need the whole length to be 7. So 2 plus 2 is 4, and 7 minus 4 is 3. So this segment, I'm going to do this segment in blue. So if this has to be 7, 2 plus 2 is 4, 7 minus 4 is 3. So if that side is 3, then this side has to be 3. It says this is 4, so that is 4. And since this is opposite to the other parallel side, so that would be 9 meters as well. So now we can find the area of the smaller rectangle, which I'm going to color in green. The dimensions will be 4 times 3, which is equal to 12. And then we would find the area of the big rectangle, which I'll color in gray. Except it shouldn't be right there. And then we would do 9 times 7 is equal to 63. And if we want to find out just the large rectangle without the green cutout, we would do 63 minus 12, which would give me 51 meters squared. So I hope you're kind of catching on to this. Got one more for us. This is one of my favorite questions. So this wall needs to be painted, and we have to find the total area that needs to be painted. However, we're not going to paint the doors. We're not going to paint the windows. So my first bet, go ahead and click pause, actually. I want you to try to work this out, and then come back and watch the explanation. Alright, so welcome back. So you know that we're not going to paint this window right here, and we're not going to paint this door. But I want to find out the total area of the wall first. So I'm going to remember that area of a rectangle is base times height, or length times width. So it's 15 times 12, which is 180. And then we need to calculate the door. So we got the door is equal to 8 times 3, which is 24. And then the window is 4 times 3, which is 12. So we would subtract, I'm going to add these together, because those are what we do not need, 36 feet. So I'm going to subtract 180 from 36 feet. And I got 144 feet. So the wall, so 144 feet of the wall, it's a massive wall that needs to be painted. So we didn't include the door or the window. Cool. So I added 3 real-world examples that are kind of challenging. They are on my website. Feel free to do them. You can print them. You can do them on notebook paper. The answer keys will be posted on Friday. Also, if you did the problems from yesterday, I did not upload those answer keys yet. I had a lot of technical difficulties this morning. I will have those by, let's say, 2 o'clock today. Just go back to the old document on the website, and the answer key will be posted to the bottom. And the answer keys tomorrow will be posted. So just remember, go sign up for a one-on-one conference. Be on the lookout for the project tomorrow. And then we have our Google Hangout on, not Google Hangout, Zoom Hangout on Tuesday. Proud of y'all, care about y'all. Hope you guys have a good rest of your day.